Alrighty, welcome back everyone. So today we're going to push forward with more DE fun. We'll be doing undetermined coefficients for non-homogeneous constant coefficient DE. So that's going to be a lot of fun. I think you'll enjoy it. But before we do that, let's tackle this homework and knock it out super fast because it's not bad at all. So let's say that we start with number 1. So you have 4y double prime plus y prime equals 0. And so when I do the auxiliary equation, I convert this into my m's. I get 4m squared plus m equals 0. So I can factor out an m, and I'm going to be left with m times, what is that, 4m plus 1, something looks like that, and equals 0. So if I just kind of look at that and solve it, I'm going to wind up with m equals 0 and m equal negative 1/4. Does that sound right? Something like that. So with that in mind, my solution is going to be y equals c1 times e to the 0x plus c2 times e to the negative 1/4x. Well, this is just a 1, so it's really just c1 plus c2 e to the negative 1/4x. Not too bad. How was that? Was that a nice quick solve compared to doing the other methods? Absolutely. So let's knock out number 3 the same way. Y double prime minus y prime minus 6y equals 0. So this is going to give me, for the auxiliary, m squared minus m minus 6 equals 0, which means m minus 3 times m plus 2 equals 0. So I get m is equal to 3 and m is equal to negative 2. So I'm going to wind up with y equal to c1 times e to the 3x plus c2 e to the negative 2x. And it doesn't matter what order I put them in. It's an arbitrary choice, so no big deal. That's our answer. Like I said, 20-second solves for some of these. So let's look at number 5. Y double prime plus 8y prime plus 16y equals 0. Well, this is going to be m squared plus 8m plus 16 equals 0. So this is just going to be m plus 4 quantity squared equals 0. So it's going to be a repeated solution for m equals negative 4. So I'm going to get y is equal to c1 times e to the negative 4x plus c2 times what? Right, x e to the negative 4x. That's how you indicate when you have a repeated root. That's how you differentiate it. So you put the x in front of your exponential. Alrighty, not bad. Let's clear this and continue on. So number 9, we have y double prime plus 9y equals 0. So I'm going to get m squared plus 9 equals 0, which means that m is going to equal plus or minus 3i, right? Because that would have been m squared is equal to negative 9. Take the square root of both sides. I'm going to wind up with this. All right, so this is my very first complex, and I need to take note that my alpha is missing. That's because alpha is equal to 0 right here. So my solution, y equals c1, there's no alpha, so, well, rather alpha is 0, so I can eliminate that piece. It's just going to be c1 cosine 3x plus c2 sine 3x. That's it. Alrighty, moving on. Number 11, y double prime minus 4y plus 5y, or y prime, plus 5y equals 0. So m squared minus 4m plus 5m equals 0. Yep, I'm going to wind up with b squared minus 4ac. It's going to wind up being negative, so I'll go ahead and work through that. My m is going to equal negative b, so 4 plus or minus square root of 16 minus 4 times 1 times 5 is 20. All that over 2 times 1 is 2. So this is going to be 4 plus or minus root negative 4 over 2. So m is going to equal, this becomes 2i, divide everything by 2, 2 plus or minus I. Okay, so we've got our alpha there and our beta there. All right, so I'm going to get y is equal to c1 times e to the 2x cosine x, because there's a 1 right there, plus c2 e to the 2x times sine x. Alpha is here, beta is what's in front of your x. Alpha, beta. Not bad at all. Not bad. So even the complex ones are not bad at all. So let's see, number 15 is next. So for 15 we have y triple prime, triple prime, minus 4y double prime, minus 5y prime equals 0. Okay, I got excited. It's not actually all that interesting. So this is m cubed minus 4m squared minus 5m equals 0. And I can take an m out. This is why it's not all that interesting. And it becomes a quadratic. M squared minus 4m minus 5 equals 0. And then this becomes m times, this is going to be m minus 5 times m plus 1 equals 0. So I'm going to get, for my m's, m equals 0, m equals 5, and m equals negative 1. So y is equal to c1 times e to the 0x, which is just c1, plus c2 e to the 5x, plus c3 e to the negative x. So there you have number 15. Not bad. Like I said, these are so simple compared to every other technique that you'll ever see in DE. Alrighty, so next one is 24. So 24 we have, fourth order, y to the fourth minus 2y double prime. When I say y to the fourth derivative, plus y equals 0. All right, so the auxiliary is going to be m to the fourth minus 2m squared plus 1 equals 0. Okay, so this actually factors into m squared minus 1 squared. But m squared minus 1 can be broken into m plus 1 times m minus 1. So I'm going to get these two solutions repeated. So my answer is going to be, let's see, it's going to be y equals e, by good sense that'd be dangerous. Let's see here. I'm going to have my c1 e to the x plus c2 e to the negative x plus c3 x e to the x plus c4 x e to the negative x. Just like that. Not bad at all. Alrighty. Hopefully y'all are like really getting into the groove with this, because this is just ridiculously fun and simple compared to what we've been doing. So let's tackle number 33 now. We have y double prime plus y prime plus 2y equals 0. And we have initial conditions. We have y at 0 is 0. Always love that initial condition. And y prime at 0 is 0. It's also a nice one to work with. So what do I have here? Well, my auxiliary is going to be m squared plus m plus 2 equals 0. And so when I work this out, it's going to be b squared minus 4ac. It's definitely going to be negative, which is going to be complex. So let's go ahead and work it out. We're going to get m is equal to negative 1 plus or minus square root of 1 minus 8 over 2. So this is m is going to equal, really not much else I can do it, negative 1 plus or minus root 7i over 2. And that's it. So my alpha is going to equal this part right here, so negative 1/2, and my beta is this part right here. So, well, if I do an equal sign, equals root 7 over 2. So there we go. So then what does that make my y? Well, y is now going to equal, we're going to have c1 times e to the negative 1/2 x cosine root 7 over 2x plus c2 e to the negative 1/2 x sine root 7 over 2. That x goes down there. X. Don't understand why I did that like raised up. That's weird. Root 7 over 2. There we go. Okay, so initial condition time. Plug the very first one in. Oh, I can already see I'm going to need more space, aren't I? Yeah, oh well. Let me go ahead and clear and start fresh because I'm going to need the room. All right, so we had y is equal to c1 e to the negative 1/2 x cosine root 7 halves x plus c2 e to the negative 1/2 x sine root 7 over 2x. And the initial conditions are y at 0 equals 0 and y prime at 0 equals 0. So let's do the first one. So if I do that, I'm going to get 0 equals, all I have to worry about is sine of 0 is 0, so this whole term is going to go away. I'm just going to be left with this. So it's going to be c1 times, this is going to be e to the 0, which is a 1. Cosine of 0 is a 1. So c1 equals 0. So that is going to be gone. Now y prime is going to equal, I guess I don't have to do this part. You know I don't. It's a 0. It's not going to make an appearance. So I'm just going to worry with these two pieces up here. So y prime is going to be c2. We're going to have first e to the negative 1/2 x times derivative of the second. So times root 7 over 2 cosine root 7 over 2 x plus the second sine root 7 over 2 x times derivative of the first, which is going to be negative 1/2 e to the negative 1/2 x. Alrighty. Now y at 0 is 0, so I get 0 equals, let's see, it's going to be c2 times, well, this is a 1 again, And then I'm going to have, this is going to be a 1, so it's going to be root 7 over 2. And this whole term is going to go to 0 because the sign of 0 is going to be 0. So I'm going to wind up with, well, C2 equals 0, right? So what is the only solution to this set of initial conditions? Y equals 0. Ta-da! All that work. That's okay. That was fun. Alrighty. So I hope you enjoyed that homework, and now we can move to something that is really elegant. You're going to like this. It's very similar to what we just did. So let me clear this and get going. Okay, so we, in the previous section that we just did the homework for, we were solving a homogeneous linear differential equation with constant coefficients. Okay, now we're going to solve a non-homogeneous DE with constant coefficients. So this is the method of undetermined coefficients. Undetermined coefficients. And when do we use it? When it is a non-homogeneous linear DE with constant coefficients. Okay, ooh, that's a lot to write. So we have constant coefficients on a non-homogeneous linear DE, which looks like what? Well, it's the same thing that we had before, where I have a sub n, y to the fourth, the nth derivative, and then that's plus a sub blah, 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 y n minus 1. Here we go. We're going to go all the way down to a sub 1, y prime, plus a naught y, and that's equal to g of x, where now all my a's are constant coefficients. So these are constants. Okay? And my g of x is not 0. If that's the case, it is a non-homogeneous linear DE with constant coefficients. Okay? So, as we talked about in the theory, and I kept like going on and on and on and on about it, when we have a non-homogeneous DE, the solution takes the form of y equals y sub c plus y sub p. Y sub c is our, wow, that's a weird name, complementary solution. Y sub p is our particular solution. And what is the complementary solution? That is the solution for the associated homogeneous equation. So to find the solution of a non-homogeneous, you first find the solution for the associated homogeneous. Okay? So all we have to do is take this equation and set it equal to 0 and solve to find our y sub c. Then we worry about y sub p. Okay? So that's going to be our blueprint for how we work this. But how do we get this part, the particular solution? So here is the theory. And this only works if g of x is something that is relatively simple and calm, g of x, I need to state this, g of x must be a polynomial. That would be fine. Exponential would be fine. Sine slash cosine would be fine. All the ones that are really simple. Polynomials, exponentials, sines, cosines. Now, when I say simple, I really should be saying they are really friendly when it comes to differentiating them. The the derivative of a polynomial is a polynomial. The derivative of an exponential is an exponential. The derivative of a sine or cosine is a sine or cosine. So if our non-homogeneous part, the g of x, is something simple like this, a polynomial, exponential, or sine or cosine, or any kind of product of these would also work just fine, or linear combination. So linear combination product, as long as it looks like this, you're good to go. If that is the case, then since the derivatives must also be of that form, like we just talked about, be a polynomial, an exponential, or sine or cosine, g double prime must also be same thing. We can actually do a very cool method by making an absolute guess of what form the particular solution has to be in. Okay? This is so crazy how it works. Let me give you an example because this will make no sense without an example. I am going to make a total guess of what my answer is going to be. So we're going to start off with something that looks like, oh, I cannot wait to show you this, y double prime plus 4y prime minus 2y equals 2x squared minus 3x plus 6. Step 1. Solve the associated homogeneous linear with constant coefficients. I didn't want to write all that. So what is that, you say? Well, solve this one. Y double prime plus 4y prime minus 2y equals 0. That is the associated homogeneous equation of the non-homogeneous equation. You just take g of x, set it equals 0, and solve. Well, we know how to do this one super fast, right? B squared minus 4ac is going to be positive. So I know I've got two real solutions. Let's see, how would this work? I can't factor this, but I can set up a quadratic formula. I'm going to wind up with m squared plus 4m minus 2 equals 0. So m is equal to negative 4 plus or minus square root of 16 plus 8 over 2. So this is going to be negative 4 plus or minus. It's going to be 24. I can pop a 4 out. That'll be 2 root 6 over 2, which is going to equal negative 2 plus or minus root 6. Okay, so I'm going to wind up for my solution, y equals, this is going to be, since it is repeated real, not repeated, since it's distinct reals, c1 e to the negative 2 plus root 6 x negative 2 plus root 6 x plus c2 e to the negative 2 minus root 6 x. This is my y sub c. Okay? Now that I've found my y sub c, and just store this in your memory bank, put it to the side, do some scratch work, whatever, because now we're going to find y sub p by making an absolute guess. So here we go. Clearing this, I'm going to rewrite the differential equation up at the top. Y double prime plus 4y prime minus 2y equals 2x squared minus 3x plus 6. Okay? I'm going to say that my solution looks just like what the non-homogeneous part is. It looks just like my g of x. So my solution, y sub p, is of the form a x squared plus b x plus c. Now if that's the case, then y sub p prime is going to look like the derivative of this, which is going to be 2ax plus b, and y sub p double prime is the derivative of this, which is 2a. Okay? So I'm going to now use these guesses with my actual dE over here, this part, and see what I get. So I'm going to do y double prime plus y 4y prime minus 2y equals, and if you want, you can say that these are little p's because I'm hunting for y sub p, not just general y anymore. So I can now substitute in, well, y sub p double prime is just 2a plus 4 times y sub p prime, 2ax plus b, minus 2 times y sub p, ax squared plus bx plus c. Okay, I'm now going to get all this done together. So if you will allow me, I'm going to drop the p because I don't write little sub p's all the time. So y double prime plus 4y prime minus 2y equals 2a plus 8ax plus 4b minus 2ax squared minus 2bx minus 2c. Okay? Now, I'm going to take all of these pieces and set them equal to this, right? Because this is equal to this, and this is equal to this. Therefore, I can set this equal to this. So I'm going to now say 2x squared minus 3x plus 6 is equal to 2a plus 8ax plus 4b minus 2ax squared minus 2bx minus 2c. All right. Now, I hope this is looking similar to something that you did in Calc 2, where we had to solve for these A, B's, and C's when we made a guess, and that was when we were doing partial fractions. We're going to do the exact same thing here. I'm going to gather all of my x squared terms together, all of my x terms together, and then all of my non-variable terms together. So this is going to become 2x squared minus 3x plus 6 equals all the x squared terms, negative 2a x squared plus all of the x terms, 8a minus 2b x, all of the non-variable terms, plus 2a plus 4b minus 2c. Okay? Why did I group them like that? Well, I grouped them like that because this x squared matches this x squared. So the coefficients also have to be equal. So I can now say, I'm going to try to do a little scratch work up here so that I don't have to erase and rewrite all this. I can say that 2 is equal to negative 2a. And if that's the case, a has to equal what? Negative 1. Okay? So all I did was I equated this with this, because they were both coefficients in front of the x squared, and they are equal. Therefore, this has to be the same as this. Now, I can take the coefficient that's in front of the x terms and set them equal to each other. So that is going to be equal to this. So up top, I'll have negative 3 equals 8a minus 2b. But I know that a is negative 1. So this whole thing is negative 8. So I can now, I'm going to move that over. I'm going to get 5 is equal to negative 2b. b is equal to negative 5/2. Okay? Now I do the exact same thing down here. I go, this term must be equal to this term. So I can now head up here and say 6 equals 2a plus 4b minus 2c. Well, a is negative 1, so this is going to become a negative 2. b is negative 5/2. When I multiply that by 4, I'm going to get negative 10. And so I move that over. I'm going to wind up with negative 12 becomes positive 12 when I move it over. So this is going to be 18 equals negative 2c. c equals negative 9. Okay? So I now know what my A, B, and C are for my particular solution. And I can now write out the final answer. Y is equal to y sub c plus y sub p. Okay? I know what my y sub p is now. Y sub p is negative 1x squared minus 5/2 x minus 9. So my final solution is y equals c1 times e to the negative 2 plus root 7x plus c2 e to the negative 2 minus root 7x. And now the y sub p minus x squared minus 5/2 x minus 9. And that is the solution to the non-homogeneous dE with constant coefficients. Ta-da! I hope that was as satisfying to you as that was to me. I love constant coefficients. So let me clear the screen, take a breath, and let's tackle a few more problems. Here we go. Clearing the screen. Alrighty, so for this one, let's see. Let's say we have y double prime minus y prime plus y equals 2 sine of 3x. Alrighty, so first thing we're going to do is solve for the homogeneous portion. So in that case, we're going to get m squared minus m plus 1 equals 0 for our auxiliary. And so that's going to be b squared minus 4ac is definitely going to be imaginary. So let's say we're going to get m equals 1, that's the negative b, plus or minus b squared, so root b squared, minus 4 times 1 times 1 is going to be 4. Hope I did that right. Negative b squared, yeah, that looks right, over 2. Okay, so it's going to equal 1 plus or minus root 3I over 2. And so this is going to be our alpha, and this is going to be our beta. So we're going to have a solution that looks like y sub c, and this is the c part, the complementary, is equal to, we're going to have c1 times e to the 1/2 x cosine of root 3 over 2 x plus c2 e to the 1/2 x sine root 3 over 2 x. Just like that. So there you have it. That is the solving it, the homogeneous, the associated homogeneous. So now we are going to work on solving y sub p. So we're going to make a guess. Y sub p is equal to, well, this one is a little bit strange the first time that you see it. My guess is not going to be sine or cosine. It's going to be both. The reason is a lot of times you're going to wind up with two solutions for your y sub p, one of which is the sine, the other is the cosine. So we're going to put both of them in as our initial guess and see how it works. I think it'll make a little more sense once we get into it. So our guess is going to be a times cosine 3x plus b sine 3x. Okay, then that means that our derivative, y sub p prime, is going to equal, well, that's not too bad, negative 3a sine 3x plus 3b cosine 3x, and then finally y sub p double prime, and that's going to be, when I take the derivative of this, negative 9a cosine 3x, and this is going to be minus 9b sine 3x. Okay, so now that we have our y sub p double prime, prime, and just the y sub p, I can now feed it in up here. So if I do that, I'm going to get y double prime. So y sub p double prime is going to be, hope I can fit all this on this thing. So this is going to be negative 9a cosine 3x minus 9b sine 3x. And then I've got minus y prime, so minus this, so plus 3a sine 3x minus 3b cosine 3x, whew, and then plus y, so plus a cosine 3x plus b sine 3x. Wow. And then this is equal to this, so this is also equal to 2 sine 3x. I don't think we'll be able to write. I might have to do like an under thing here. 2 sine 3x. I was hoping I'd get it all on one line, but no such luck. But on the very, very bright side, a lot of this stuff is going to collapse. Not a ton, but some of it. So let's see if we can find anything that are similar. So first thing I want to do is my cosine 3x's, and if I look at that, I'm going to wind up with negative 9a for this one. I'm going to cross as I go because there's a lot of stuff going on. Minus 3b, and then plus a times cosine 3x. Okay? So now that I've got that, let's see, it's going to be for the other one, for the sine 3x, negative 9b, oh, I forgot to cross out this one, plus 3a, cross out that, plus b, and this is sine 3x, okay? and then this equals 2 sine 3x. Okay, I can condense this a little bit. This is going to become negative 8a minus 3b. There is no cosine 3x from over here, so this is going to be equal to 0. And then when I've got negative 9b plus the positive b, this is going to be negative 8b plus 3a is going to equal, well, it has to equal to 2, right? Okay, so I wind up with a system of equations that I can solve. I'm going to do that on the next page. Let me clear this. Clear this. I need someone to like set up a quarter jar every time I fail to clear the screen. I'd be rolling in the dough. Let's see. So I have negative 8a plus 3b equals 0. And then 3a minus 8b is equal to 2. Okay? Let's see, which one do you want to drop first? Doesn't really matter. We can drop either one. Let's eliminate the b's just for fun. I'm going to multiply the top by negative 8 and the bottom one by 3 to do that. So I multiply the top by negative 8. I get 64a minus 24b equals 0. And then 9a plus, oh, I didn't have to multiply by a negative. Oh, that's silly. Yeah, that's positive. They're already different signs. Hello, wake up. So there we go. And then this is going to be minus 24b equals 6. Alrighty, that looks a little bit better. So now when I add them together, I'm going to drop it out and wind up with the 24b's canceling, and I have negative 55a equals 6. Does that look right? Seems strange. Negative 64a, 24b, 0, 9a, negative 24b, positive 6. I guess that's right. That's not what I have on my paper, but I may have solved it incorrectly. Oh well, no big deal. Now I can solve out. A is going to equal negative 6 over 55, and I don't think we can do anything with that. Can't. 2 and 3 and 5 and 11, nothing in common. So now that I've got my A, I could feed it back in and deal with the fractions. I'm just going to eliminate A's though by multiplying both of them by kind of the opposite saying 3 and 8. So if I do that, I'm going to wind up with negative 24A plus 9B equals 0, and then 24A minus 64B equals 16. And so now when I drop them out, I'm going to wind up with negative 55b equals 16. So b is equal to negative 16 over 55. Again, can't do anything to make that more compact. So with that, all I have to do now is rewrite my y sub p. So y sub p, the guess that I made was I had a cosine 3x, so negative 6 55ths cosine 3x plus, or rather minus, since it's a negative, minus 16 55ths sine 3x. So it turns out that that particular solution, even though my initial non-homogeneous part only consisted of a sine 3x, the particular solution is a combination of cosine and sine, and you're going to see that happen with regularity. So now that I've got my y sub p, I would just do the y equals and then all that stuff from the first. And if you're wondering why I'm not doing it, I didn't write it down, so I have no memory of what I did. I can't refer back to what I solved for. So we're just going to assume I did y sub c plus y sub p and everything's happy. Alrighty. It's very satisfying when you write it all the way out. Sorry, I didn't write that down. Okay, so Let's do one more, and this one let's do where we have an exponential as our non-homogeneous part. So let me clear this. Let's knock that one out. So y double prime minus 2y prime minus 3y equals 4x minus 5 plus 6x e to the 2x. I'm not going to worry with the homogeneous part. I can look at that and tell that's minus 3 positive 1, so that's an easy solve. I'm not going to spend the time on that, but I am going to worry about this because this y sub p is not simple. This one is a kind of a bear. So here we go. When you have something like this, what you have is a combination of two types of guesses. This one is a polynomial, and this one is an exponential. So we can't just kind of glom everything together. What we need to do is solve for each piece separately. And is that legal? Yeah, that's absolutely legal because any linear combination of solutions is also a solution. So that is totally fine to break this into two pieces. So I'm going to call the first chunk y sub p sub 1. So y sub p sub 1, the guess for that is going to be, well, it's just a first order, so it's going to be ax plus b. That means y sub p1 prime is going to be a, and y sub p1 double prime is 0. Okay? Now over here for this one, I'm going to call that y sub p2. So y sub p2, the guess for that is going to be, there is an x e to the 3x. In order to make sure that we have the entire solution, we want to not just have x e to the 2x, but also e to the 2x. Just like when we had the sine and the cosine, if you just have one of them, you still write down both parts as your guess for your solution. Same thing when we have an x times an exponential. You have to write down x times exponential plus just the exponential by itself. Because they kind of go in pairs, don't they? In the solutions, when we have repeated roots, you have your solution is x times e to the whatever, and then just the e to the other. Well, same thing here when we're working backwards. So we're going to say our guess now is going to be c times x e to the 2x plus d e to the 2x. There we go. So now y sub p2 prime, well, the derivative of this is just going to give me 2. Oh, wait, no, I can't just do that. That's a product. Whoops. All right, so it's going to be, let me erase that part. All right, so it's going to be c times, first times derivative of the second, 2x e to the 2x plus second times first, e to the 2x times 1. Okay, and then this one's going to be d, oops, I can put the 2d e to the 2x. Okay, now I'm going to write it a little bit better, make this 2c x e to the 2x plus just c e to the 2x plus 2d e to the 2x. Okay, so now that I've got that written out, I can go from a y sub p2 double prime. So y sub p2 double prime is going to be, well, the derivative of this is exactly what we had when we took the derivative of this, just an extra 2 on it. So I just have to multiply what I have here by 2 for this derivative of the first term. So this is going to be 4c x e to the 2x plus 2c e to the 2x. That takes care of the derivative of this term. Now take the derivative of this one, and it's going to be plus 2c e to the 2x. And then the derivative of this one, which is going to be plus 4d e to the 2x. And now I can combine that I'm going to have 4c x e to the 2x, and then plus 4c e to the 2x plus 4d e to the 2x. And there we go. We now have our primes and double primes for both of them. Alrighty. So this is going to be a lot of fun. I hope you enjoy this. So we can do this two different ways. One of the ways is to match this up with our guesses when we build our guess equation, I guess you could call it. I don't know what the proper term is. And then we can do the same thing over here when we're dealing with this piece. That's probably the nicest way to do it. For some reason, when I was doing, I just made one giant thing, but I think I'm going to break it into pieces and solve each one individually. That's going to be a much easier thing to do. So let me first build this DE with my y sub p1s. So y double prime is just going to be 0. So 0 minus 2 times y prime. So y prime is a minus 3 times ax plus b, and that's going to equal 4x minus 5. Okay, so when I distribute this, I'm going to get negative 2a minus 3ax minus 3b equals 4x minus 5. So now I can factor out my x piece and get negative 3ax, and then my non-x term plus negative 2a minus 3b. That's going to equal 4x minus 5. Alrighty, so if I do that, now I can say that negative 3a has to equal 4, which means a has to equal negative 4/3, right? Okay, so if a is negative 4/3, I can now plug that in right here. And if I do that, I'm going to get negative 2 times negative 4/3 is going to be 8/3 minus 3b equals negative 5. So this is going to be negative 15/3. And when I add negative 8/3 to that, we're going to get negative 3. Oh, I just went off the screen. Hold on. Whoops. Let me just swing that over here. So negative 3b is going to equal negative 23/3. Divide by negative 3. B is going to equal 23/9. So not bad. I have solved for this part of the non-homogeneous. Now I need to solve for this part using these. So I'm going to clear the screen. Unfortunately, there's no room here, although I could erase. Yeah, I'm going to erase because I want to keep this. I don't want to have to do everything twice. So let me erase down here. Erase. Bump up the size of the eraser. Alrighty. So I like this a lot better than having to erase the physical board, I can tell you. So here we go. Let's see if we can fit all this on here and get this knocked out. So I've got this right here. So 4cx e to the 2x plus 4c e to the 2x plus 4d e to the 2x is going to equal 6x e to the 2x. Okay, I'm going to factor out my x e to the 2x, so it's going to be 4c times x e to the 2x is going to equal 6x e to the 2x. Well, that's not bad at all. That means 4c equals 6, so c equals 3/2. Okay, so now that I've got that taken care of, I can move into the next one. And for that one, I'm going to have It's weird. 3/2, 4c. Sorry, I'm looking at my paper, making sure that I'm doing this right. Just there's a. Did I get that same answer? I did not get the same answer, which is kind of weird. Huh. Did I mess up? Let's see. 4c ex e to the 3x. Okay. Well, I've come too far at this point. If I made a mistake, sorry, the mechanics are the same. I just probably made a sign error somewhere. So I now have a solution for my c, and now I can move into the just the e to the 2x's. So if I do e to the 2x's, I'm going to wind up with 4c, that one, plus 4d times e to the 2x equals 0. There are no e to the 2x's over here. So I've got 4c plus 4d equals 0, but I know that c is 3/2. So when I multiply that by 4, I'm going to get 6 plus 4d equals 0. D is going to equal negative 3/2. Okay? So now I have what my y sub p is here. So now that I combine all that together, and I don't have room, I don't think, I will just kind of scroll it down over here. So my y sub p, this is just the y sub p, not the y sub c, but the y sub p is going to equal, I've got my a and my b that I solved for previously, where a was negative 4/3, so negative 4/3 x, and b was 23/9, so plus 23/9. And then I've got my c and my d here and here, so plus, I've got c is 3/2, so 3/2 x e to the 2x plus, or minus, since that's a negative 3/2, so minus 3/2 just plain e to the 2x. That's my y sub p right there. And so I just add that to the y sub c, so I get my final general solution. Hooray! Again, apologies if I messed up any of the math, and I would not be surprised because this is interesting stuff. Alrighty, so any questions on that? Okay, I'm now going to show you the last thing before I turn you loose with some homework. This next thing is it comes up with surprising frequency. You will probably see one on the final exam, so hint, hint. Let's say I have y double prime minus 5y prime plus 4y equals 8e to the x. Okay? Now, I'm actually going to solve this, the y sub c, completely. So I'm going to have, when I do my auxiliary, m squared minus 5m plus 4 equals 0. So I'm going to get m minus 4 times m minus 1 equals 0. So my y sub c is going to equal, I'm going to have e to the 4, blah, 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 blah. C1 e to the 4, negative, positive 4, yeah, positive 4x plus C2 e to the x. Okay? Now, I'm going to move to the non-homogeneous solution, and I need to make a guess. But here's the problem. Well, actually, I'll give you a second to look at it. Do you see a problem with going straight to the guess? Yep. I already have that form in my y sub c, so I can't use it as part of my guess for y sub p. So in this case, since the e to the x has already been taken by the y sub c, we're going to make our y sub p our guess. It's just going to be ax e to the x. And we're not going to do the plus e to the x because that one is already taken. So now that I've got it in this form, I can do the y sub p prime. And that's going to be what? A x e to the x plus b e to the x. B, my gosh, if I had good sense, that'd be dangerous. Let me lower the size so I don't knock out half the page. Alrighty, there we go. And so A, there's no B, right? So then when I do y sub p double prime, I'm going to get, well, pretty much the same type of thing, right? It's going to be the derivative of this was the derivative of this, so it's going to get ax e to the x plus a e to the x plus a e to the x. So my y sub p double prime is going to be ax e to the x plus 2a e to the x. Okay? So now I can build my guess using the differential equation. So I've got y double prime, so it's going to be ax e to the x plus 2a e to the x minus 5 times y prime, so ax e to the x plus a e to the x, and then plus 4 times y, so plus 4 times ax e to the x, and that equals 8 e to the x. Okay, so I'm going to gather all these like terms, and there's a lot of them. So let's do the x e to the x terms. I've got 1 here, minus 5 here, plus 4 here. Well, what do you know? They all go away. That's a 0. 1 minus 5 plus 4, 0. So now I just have 2a e to the x minus 5, so negative 3. Negative 3. That's going to be it. So negative 3a e to the x is equal to 8 e to the x, which means that negative 3a equals 8a equals negative 8 thirds. So my y sub p is negative 8 thirds x e to the x. My whole solution would be y is equal to c1 e to the 4x plus c2 e to the x minus 8 thirds x e to the x. That is my general solution to the non-homogeneous linear differential equation with constant coefficients. Okay, so that's the way you handle all that. That's an example of all the different types of guesses you might have to make: polynomials, sines and cosines, exponentials, and even one where you wind up in your complementary solution, your homogeneous solution, one of the guesses that you would make in your non-homogeneous guess, which eliminates it. So you have seen it all now. You're ready to go. Let's see. You know what? Your book did do one thing really interesting that I want to show you before I turn you loose. I know I said I'd turn you loose right after, but I forgot that your book did this one thing really, really, really nice. So let's say I have x squared minus 3 as my non-homogeneous part. What type of guess would that be? It would be a x squared plus bx plus c. Even though there's not an x over here, I still include that in my guess. That's the same thing, kind of reasoning behind if I have sine 4x, I am going to have a cosine 4x plus b sine 4x as my guess. Okay? Then if I have something like 5x squared sine 4x. Okay? this looks really strange, but this is the way you would make your guess. This is a polynomial. It's a quadratic term multiplied by a sign. So I'm going to have, here we go, ax squared plus bx plus c times cosine 4x plus dx squared plus ex plus f times sine 4x. Okay? And last but not least, x e to the 3x times cosine x. Ugh. What is that going to look like? Well, this is a first order, so I can get away with ax plus b times e to the 3x cosine x plus cx plus d times e to the 3x sine 4x. That's something, isn't it? We did not have to do the x e to the 3x in this case. It is already over here. Why don't we have to do that? Oh, duh, I'm looking at it wrong. We already have the x right there. That's why. I was going, wait a second, something's terribly wrong. No, that is exactly right. The x is already here in our, when we do the linear piece for the polynomial, it already has it in there. Alrighty. So this is how you would guess for various more complicated non-homogeneous pieces. To be completely honest though, I've seen this maybe once. I don't think I've ever seen this. I've definitely seen these two though out in the wild. But this one, I've never seen it come up where you have kind of a triple thing going on, triple product. Alrighty, so let me give you the homework. And it's just going to be 3 problems. So this is from section, what is this section? This is 4.4. So 4.4, numbers 3, 19, and 29. And so star, star, and star. Okay? So knock those out. They're actually a lot of fun, as you've seen. These non-homogeneous with constant coefficients are actually enjoyable. This setting up this guess is so much fun. I truly enjoy doing this kind of stuff. This is very, very satisfying. So give it a go, try it out, and I will see you next time. Take care, stay safe. Bye-bye.